So this is my speech for my Biology 1020 class on how climate change has affected the region of Appalachia, specifically the geography of it, I guess. My name's Grant King. So how has climate change affected the geography of Appalachia? Before we get into the details of how it has done it, let's talk about some defining factors. The biggest factor of it, and the one we'll spend most of this speech talking about, is erosion. But what is erosion exactly? Well, erosion is the process of something eroding, but eroding itself is described by the dictionary as wind, water, or other natural agents gradually wearing away soil, rock, or land, and that's from the Oxford Dictionary. This is basically giving us the definition of how it is a destructive process of natural forces that slowly gets rid of the geography of land. But how has this happened in Appalachia, specifically this area? We have seen a great shift in the land due to the increased rainfall and temperature changes, mainly brought on by climate change and pollution, which has drastically affected how it looks. I mean, you can see bigger ruts, like if you go up on Brimstone towards Scott County, Tennessee, there are ruts that run up that road. But one way we see this is from Nicholas Barnes. He has a PhD in geography, and he has told us that 2 prior projects at the study site have investigated the region's gullied soil characteristics and precipitation parameters. In the first study, silty clay-rich utisols have derived from Ordovician to Cambrian age siliceous dolomite and magnesium limestone record from eroding and non-eroding sites. An assessment of the soil's physiochemical properties found that a silty clay texture increased bulk density and reduced its hydraulic conductivity in the BT horizon, and soil subsurface tunneling by burrowing animals are good indicators of gully erosions in the southern Appalachian utisols. Another study in the same area by the same man, but a different study of this exact thing, examined that the role of precipitation accumulation, duration, and intensity on gully erosion, and it concluded that different morphological settings within a gully respond to different difficulties. This is from the gull erosion and freeze-thaw processes in clay-rich soils in northeast Tennessee, and it was by Nicholas Barnes. This shows how rapid temperature changes specifically can affect the geography of places. And if you've lived in Appalachian Tennessee, in East Tennessee or the Appalachia for any amount of time, you have learned that we can change temperatures drastically. I mean, I can go outside right now and it could be 40 degrees, and in a couple hours we'll be in high 70s. I mean, it just changes, and then the humidity increases that moisture in the air and changes it up even more. And that temperature change is what has caused such a change in our geography in such a short amount of time. Another way we have seen the geography of the land change is through the topographic relief that has increased. Scott Miller, is a biological science major, and he has a PhD, and he shows us that his results, his direct quote says that our results support a growing number of studies inferring that topographic relief in the central and southern Appalachians has increased during the late Cenozoic. And that in conjunction with that's the end of that quote, and in conjunction with this other quote, he says these results argue strongly that a recent increase in topographic relief in the Susquehanna River catchment is a result of perturbation in erosion rates propagating through the fluvial network. Moreover, the regional context of the wave of transient incision implicates a driver that acts as wavelengths of hundreds of kilometers. That is from the article Neogene Rejuvenation of Central Appalachian Topography. It's an evidence for differential rock uplift from stream profiles and erosion rates. That was done by Scott Miller. That quote right there shows how perturbation propagating through the soil has caused eroding of multiple land pieces. It has been a very major change in the land. One other way we've seen this is through rainfall. Savage Humir states that this study investigated potential changes in future rainfall erosivity due to climate change in the New River Basin of the southern Appalachian region for the time period 2010 to 2099. Now I'm going to end that quote real quick to tell you that this is also not just what has already happened, but it's going to give us like the future all the way up to 2099. It's a prediction as much as it is a recovering of history. But to continue that quote, he says, for GHG emission scenarios B1, A1B, and A1FI of the CCSM model, results showed that for all three scenarios over the long term, the rainfall erosivity may increase with similar monthly distributions throughout a given year. This has come from the article Potential Changes in Rainfall Erosivity Under GCM Climate Change Scenarios for the Southern Appalachian Region. And that was from Mr. Savash Humier. So like I said before, this is going to show us all the way up to 2099. It shows us that we will see an increased loss of geography from the effects of climate change due to how much rain we have been getting recently and how intense and puddling it has been. To build off that, like I said, we was having like a puddling and a accumulation of rain. Ingrid Luffman is another good professor. She says that the gully morphology, hill slope erosion, and precipitation characteristics in the Appalachian Valley and Province southeastern USA. And end quote. And in conjunction with the other quote, precipitation duration and accumulation are more important than storm intensity in initiating and propagating erosion. But antecedent precipitation is a stronger predictor of erosion than either precipitation duration or accumulation. That was from the article Gully Morphology, Hill Slope Erosion, and Precipitation Characteristics in Appalachian Valley and Ridge Province, Southeastern USA. That was by Ingrid Luffman. Now with these two quotes, it's giving us I guess what you could call it is like the worst factor of it. Now, all of it is bad, but that worst factor of it is the fact that it is accumulating and sitting there. And that is what that's what's really getting us. That's why you have, like I brought up earlier, the ruts in the roads at Brimstone, because they're all puddling right there in the middle and it's destroying that middle section only. Antecedent precipitation is worse than that though. And this experiment took place in Blountville, Tennessee, so not very far from where we are right now. So, what have we learned from this? We've learned that climate change has affected the geography of Appalachia. I've told you how, the puddling is the worst thing you can get except for antecedent precipitation, of course. Showed you how the temperature change, especially around here, going from freezing temperatures to extremely high temperatures in the evening, can really mess up our awful clay soil that we have, and how that the Utisols have really combined in a wrong way to change the topographic relief in the Susquehanna River, which is being happened to all our rivers. So it has happened, and we will see that from Mr. Savash Humier that it will continue to happen in his speech, in his article that he gave us all the way up to 2099. So this is a good example of why we have had a geography affection in Appalachia in the negative way. Thank you.